Problem like this will be on a test where you have to do surface area and volume of a shape. That means you have to understand the difference between surface area and volume. And that doesn't work if I just go, it's B. That doesn't help you know either one of those for the test or anything. So we're going to go through both of these. First, we'll start with surface area. Surface area is what is the two-dimensional area of every shape that makes up this three-dimensional shape. So to make a cylinder, you have to have a top circle, it has a bottom circle, and it has a rectangle as that cylinder shape. Surface area is the area of these two circles added together and the area of this added to it. Well, the area of a circle is just pi r squared. And for this circle, it says the radius is 5, so it's pi times 5 squared. So the area of this is 25 pi. Well, if the area of that circle is 25 pi, then the area of this one is also 25 pi. Well, the area of a rectangle is length times width. Well, it tells us that the height of this is 20. What's the width of it? Hamza. What was that?
10 pi.
It'd be 10 pi. How'd you get 10 pi, though?
You just do the circle.
Yes. This length right here is the circumference of the circle. Because as I've demonstrated, if I have a cylinder, the width of it is that circumference of that circle that it forms. Because when I open it up, it's still that same length. So that is our circumference of our circle. So this width is going to be circumference, which is 2 pi r, which is 2 pi times 5, which equals 10 pi. So the area of this rectangle is 20 times 10 pi, which equals 200 pi. So the surface area of this shape is going to equal 25 pi plus 25 pi plus 200 pi, so that would be 250 pi. That is not one of those answers. There's no surface area that's 250 or 350 and 750. So maybe I made a mistake and it's 350, so let's check. We have to complete the volume. Well, remember with volume of any shape is base area times height. The only difference we came up with is if it's a cone and it comes to the point, it's 1/3 that. But it's always going to be base area times height. And you're not including both base areas because you already are. When I do base area times height, you're stacking your base however many times and it gets to the top. So our volume equals base area times our height. Well, our base is a circle. So our base area would be pi r squared, pi times 5 squared, times our height. Our height on this one is 20. So 5 squared is 25 times 20. What's the correct answer? Yeah. Yep. It would have been 500 pi, and it would have been B, 500 pi. This is an important question because I heard it going around. People didn't even know what the surface area was or what the difference was between surface area and volume. You have to know this difference. It should also be centimeters cubed. But yeah, Hamza.
We should only do 1/3 if it meets at the point.
It's only 1/3 if it meets at the point. But you should always go base area times height. Because even if you forget the 1/3, at least you have the base area times height. Know that when I ask for volume, I'm looking for base area times height. If it comes to a point, then it's 1/3. Sometimes it'll be half, because maybe I'll cut it in half, and it's going to be half that. So if I cut directly down here, you'd go, okay, it's just half of that cylinder. So then it would be 1/2 your base area times height. But base area times height, volume, know what two-dimensional shapes make up all the three-dimensional shapes we're talking about, particularly that cone. If you don't remember, cone had a special formula for coming up with the area of the actual cone portion. That was that pi r L. If you have no idea what I'm talking about, you might want to go back to your surface areas and look at cone, because that's one that you have to have memorized. All right, so that's our bell work. Any questions on surface area and volume? All right, and what questions did we have from the homework? Our homework would have been that 12.3 is volumes of pyramids and cones. That's where we got that 1/3 from. Cassie. 14? All right, so 14, they gave us like a shape. On 14, they basically, so they put it on the XY plane, but let's talk about what shape they gave us. They gave us like a triangle. So they gave us this triangle. And the important thing is, if we look at the XY plane, we had 1, 2, 3. This distance would be 3. The height was 1, 2. That was up 2. And then I guess we could have our XY thing. Well, the problem says that we're going to determine the volume of the solid by rotating the shaded figure around the y-axis. So this is our shaded figure. And what they're doing is, if you picture this shape, we're going to flip it across this way. And we're going to spin it really fast so it looks like a three-dimensional shape. The other thing I can think of is, do you guys know like those party balls that you put on the ceiling, but they come flat, and you actually open them up, and they turn into like a, I don't even know how to describe it, a cardboardy texture. Do you know what I'm talking about? But it basically turns to two-dimensional, and you open it up, and it turns into three-dimensional. That's what we're doing here. We're opening this up, and it's going to turn into this three-dimensional cone. So when we're done rotating this, this is actually going to turn into an upside-down cone. That looks horrible drawing, but can you picture that cone that I'm drawing? All right, and we have the height of it is 2, and we have the radius is 3. Well, it's just base area times height. Base is, are you good from there, you think? Okay, good. Other questions? Yeah?
You need to do something with like pi RL.
We do not have to do pi RL. It just asks for the volume.
Okay.
And remember, volume equals base area times our height. Well, base is a circle, right? So it's just pi r squared. We know the radius is 3. So this base area would be pi r squared. And then it says, what's the height? Well, the height is 2.
Okay.
So it'd be pi r squared times 2.
So pi RL is only for the length of the...
Pi RL is only when I'm asking for the surface area of a cone. So pi RL came in when I said, well, if I have a three-dimensional cone, let's draw this one a little better than the other one. So I have a three-dimensional cone, right? And I break it apart into its individual sections. Well, we have a circle on the bottom. And then remember I said if I split this in half and open it up, it'd almost look like almost the same shape. It'd just be a little wider. Be like that. So I cut that in half and I open it up. It's going to look like that. The area of this is pi RL. This is still pi r squared, though. So the area of this one would be pi RL. But you never need to know the area of this when I'm looking for volume. Because volume, the only area I need is the base. So this would be base times height divided by 1, or times 1/3. But if I ask for surface area, then I need that pi r squared plus the pi RL, where that L is this length right here. So this would be my L right here. My radius would come from the circle still. So this is strictly for surface area. For volume, you just need base area times height. Other questions from the homework? Yeah?
Can you go over 13?
Yeah, sure. There's actually a mistake on 13. It's not huge. I just have a slight error in my graph. I have a number that's wrong. But we can correct that right now. So if we look at 13, 13 wasn't meant to be a super long problem. It was actually supposed to be really quick. You just had to really think about what was happening. So they're saying you're turning on a spigot. It's going at one rate. And we have this cone. It's upside down. And they're saying graph how the height is changing over time. Well, if I just turn something on, and if we look down here, the diameter is really small. So it's going to fill up really quick. So when I first turn this on, it's going to fill up really quick, and then it's going to kind of slow down as it takes more and more water to rise the level. Can you kind of picture that? So the smaller it is diameter, the faster it's going to rise. So as I fill up, it's going to go fast, 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 and it's going to start slowing down, and slowing down. So that's what this graph is. It's saying, well, at first, the water rises really fast, because say this is 10 seconds. Within 10 seconds, it rose half the way up. And then if we look at the next 10 seconds, it is slowing down, maybe like a quarter of it. And by the time we get to the very top, it's tapering off, and it's filling very, very slowly. Your problem is flip it. Flip it, and now what does this graph look like? So when I flip it, and I'm filling from the top here. So now I'm filling top here. When I first put water in, it's going to take a long time to fill that bottom up. It's going to start going really slow at first, right? Well, the further up I go, the less water is going to take to rise. So this is going to start off very slow, and then it's going to speed up until it gets to the top, and then it kind of like overflows. So that's what this graph is. It starts out very slow, and this is it picking up pace. This number right here should actually be 50, because it was 50. The height was 50. So this should actually be 50, but the graph itself is correct. It starts out very slow, and then it speeds up near the end. Other questions from the homework? Hamza.
On number 12, I got 896 rounded to 8. I think, don't you have to divide 2,688 radical 3
By 3. I think I already did that. I have that as my work. So I came up with, so we have a pyramid, has a regular hexagon and a base. So we just need to do base times height divided by 1/3, right? And it says the base is 21. Well, to get the area of a hexagon, that is going to be half our apothem times our perimeter, right? So I came up with basically my apothem being 8 square root of 3. Is that what you got?
Yeah.
Okay. So it'd be half our apothem, which is 8 square root of 3. I multiply that by its perimeter, which would be 16 plus 16 plus 16 plus 16 plus 16 plus 16, which came out to 96. So I did half 8 square root of 3 times 96 and multiplied that by 21.
Oh, it's not. Oh, the apothem isn't 8 radical 3 over 3?
It is not.
Okay.
Because we came up with, this was the 30/60. So my 30 degrees was across from that 8. So this is s squared root of 3, so it would be 8 squared root of 3. Yep. So that's where the extra dividing by 3 came in. Other questions? These are all really good questions. Let's go over those problems. All right. Well, if you look at today, we don't have a lesson today. We're not learning anything new today, but there are some more challenging problems. And they're ones that get to the heart of, do you understand its base area times height? What is your base area? What are we talking about when we're doing that? And there's some interesting paper ones where we roll up papers and you have to come up with the volume of those. And just coming up with ratios of volumes to water in a container and stuff. So there's really good, interesting questions on here. So work as hard as you can. Whatever you don't get done is homework tonight. If you can get it done in class, then you don't have homework, I guess. All right, guys, the rest of the time is yours, though. Make sure your homework